Hello students, myself Manuj from Scholars Forum. Again I welcome you all to this homemade video series of class 11th and class 12th topics. In the previous video of mole concept, we studied about the empirical formula. I gave you the assignment as well in the very same video. Now, today we will be starting a new topic called stoichiometry. Okay. Now onwards, as I told earlier, I have started giving a small DPP on the questions related to the very same topic. You can find the link to that DPP in the comment section as well as in the description. Okay, so let's start stoichiometry. It is very interesting, and let me tell you, it is one of my favorite topic. Okay, so we will try to learn this topic in a very easy manner. Easy manner means we will try to eliminate formulas. There are so many formulas in this topic. We will try to eliminate formulas just like we did in molality question. What we did in that, we tried to learn the basics of the terms. In the same manner here in stoichiometry, we will try to avoid formula as far as possible. Okay, we will try to bring some very elementary methods of calculation. I hope you know those methods. I call that method unitary method. So we will be taking help of that and we will be solving the questions. Okay, now let's see. What is the stoichiometry? Stoichiometry is actually made up of two Greek words. First, stoichion and metron. Stoichion means related to element and metron means to measure. Okay, elements, measurement. Okay, this is the meaning of this stoichiometry. And how do we define this? We define it like a study of quantitative. Quantitative means related to quantity. Study of quantitative relationship between two or more substance participating in a chemical reaction. Okay, suppose there is a chemical reaction going on and there are two or more than two particles two or more than two substances. We want to relate them quantitatively. Quantitatively means the amount of X required react with X amount of Y, like that. Means we need to measure the quantity of one with respect to another. So this relationship between the quantities of those elements is measured under the branch of chemistry called stoichiometry. Okay, so stoichiometry, what we do, we simply measure elements. Is this clear? Now let's see a relation. As I use the term relationship. So chemical reaction is nothing but it is the relation between two or more objects appearing in a reaction. Let's see. So let's see a reaction. A plus 2B, arrow mark, 3C plus 4D. Okay. Now let's say this reaction is balanced. This reaction is balanced reaction. Okay. Now what we will learn from this reaction, let's see. And please pardon the background noise, as you know that this video is being recorded at my home. So let's see. Now I hope you can see here 1A. See, this one is not written here, but it is assumed that one is written. So even if we don't write one here, but we will read it as one. So let me read what I want to say. 1A is reacting with 2B. Okay, and both when react, they give us 3C and they give us 4D. Okay, again I am reading. Let me write that what I am reading. Here it is written, 1 mole of A, can you see the one? Yes. So 1 mole of A reacts with, can you tell me how many moles of B? What is written here? 2 moles of B to give what? 3 moles of C and 4 moles of D and 4 moles of D. You're getting this? If 1A reacts with 2B to give us 3C and 4D. Now what are these 1, 2, 3, 4? So 1, this number written here, number written here, number written here, or number written here. These all numbers are called stoichiometric coefficient. These all numbers are called stoichiometric coefficient of respective substance. What is the meaning of this? Means what is the stoichiometric coefficient of A? The stoichiometric coefficient of A is 1. What is the stoichiometric coefficient of B? 2. What is the stoichiometric coefficient of C? 3. What is the stoichiometric coefficient of D? 4. Is this thing clear? This relation says that whenever 1A will react, so 2B will also react. It's not like if one can react alone and 2B can react alone. No, both are required at the very same time. So if 1A wants to react, it will require 2B. If 2B are not present, 1A cannot react. Are you getting this? Similarly, 2B cannot react by itself. It needs 1A. Now, 1A reacts with 2B. Now, whenever they will require, so what they will give us? They will give us 3C as well as 4D. Are you getting this thing? What do you mean by 3C? 3C means 3 moles of C will be formed when 1 mole of A will react. So 3 moles of C will be formed, but not alone. Along with 3C, 4D will also be formed. Are you getting this thing? So let me write this thing as well. Means, let's see the relations. As I told you, this is nothing but it is relationship. So let's see what is the relation. So I am writing if 1A reacts. If 1A reacts, that means how many moles of B will react? 2B will also react. And what else will happen? 3C will form. And 4D will also be formed. Are you getting this thing? Okay, means whenever 1A will react, so 2A will also react, 3C will be formed and 4D will be also formed. Okay, now suppose I don't have 1A. I don't have 1A. I have 2A. I have 2A. So if 1A reacts, so how many B react? 2. Means if 1A reacts, so how many B react? 2B reacts. Are you getting this thing? But let's say I have 2A. I am rich. I have 2A. I am not poor. So if I have 2A, so can you tell me how many B will react? So if 1 reacts with the 2B, so 2A will react with 4B. So it's just a relation, isn't it? Okay, if I have 100 rupees and you have 200 rupees, we always maintain our ratio. Okay, so if I will have 200, so you will have 400. Like that. If A will react, 1A reacts, so 2B will be also reacting. So if I have 2A, so 4B will react. And accordingly, C will also change. Like 1A reacts, so how many C are formed? 3. So if 2A will react, how many C will be formed? 6. Let's see. 1A reacts, so we get 3C. So if 2A will react, so how many C will we get? We will get 6C. How we are doing this? How we are doing this? It is just like 1 rupees give me 2 toffee. 1 rupee give me 2 toffee. So 2 rupees will give me 4 toffee. Okay. 1 chocolate costs 3 rupees. So 2 chocolate will cost 6 rupees. Like that. Now tell me one thing. I ask you a very simple question. Listen and try to answer. If 6C are formed, if 6C are formed, so how many D are also formed? If 6C are formed, so how many D are also formed? Can you answer this? Okay, if you can, answer me in the comment section. Okay, now please note everything written here. Okay, one more thing you can ask me is, sir, why did you take this reaction? A plus 2B gives 3C plus 4D. This is my favorite reaction. Why it is my favorite reaction? Because it is the most elementary things that we study in our childhood. I hope if you ask any kid, if a kid, you have kids surrounding you or maybe somewhere in your relatives. So if you ask him or her, do you study? So he will or she will say, yes, I do. So what do you ask? What do you ask him? You ask him like, tell me what is ABCD, isn't it? We never say, tell us what is ABCDE. We always say कि ABCD सुना दो. It's not like हम लोग कहते हैं कि ABCDE सुना दो. So we say ABCD सुना दो. So ABCD सुना दो. And let's say कि when we ask about the numbers to the students or to the kids, we say, okay, चलो tell us 1 2 3 4. ओके हम लोग यही तो कहते हैं चलो 1 2 3 4 सुनाओ. We never say कि 1 2 3 4 5 सुनाओ. Will you say it? Try to ask a child कि tell me 1 2 3 4. Will you say 1 2 3 4 or 1 2 3 4 5? You will always say 1 2 3 4. You see, try to think. You will not say 1 2 3 either. You will say 1 2 3 4. So see 1 2 3 4. So the two most basic things that we learn are included in this reaction, ABCD and 1 2 3 4. Okay, let's move forward. Now, before moving to the next concept, let's understand some reactions which will be involving in this topic. Okay, so some important reactions. First is heating of bicarbonates. Do you know what is the formula for bicarbonate? Bicarbonate ion means HCO3 minus charge. Okay, means its valency is 1. So if you heat any bicarbonate, you get carbonate. Carbonate means CO3 2 minus ion. Okay, plus CO2. CO2 is evolved. This arrow going up, it means that CO2 is being liberated. This arrow down means it is getting deposited. And plus H2O. Okay, so this is a general reaction for heating of bicarbonate. For example, if you heat sodium bicarbonate formula means sodium valency is 1, bicarbonate valency is 1, so formula will be NaHCO3. So if you heat NaHCO3, so it will give you Na2CO3 plus CO2 plus H2O. For balancing purpose, by hit and trial method, I wrote here 2. If I put 2 here, this will be a balanced reaction. Okay, let's take another example. CaHCO3 whole twice. CaHCO3 whole twice means calcium bicarbonate. What is valency of calcium? Calcium valency is plus 2. So formula will be CaHCO3 whole twice because bicarbonate has valency 1. Now if you heat it, what we will get? Carbonate. Carbonate means CaCO3 plus CO2 plus H2O. Okay. Now heating of carbonate of alkali metals. Alkali metals means sodium, potassium, rubidium, cesium, like that. Okay, the metals belonging to first a group of periodic table are called alkali metals. So alkali metal carbonate means just like Na2CO3, K2CO3, etc. If you heat them, so no effect. Means if you heat first a carbonate, there will be no effect on them, means they will not give you anything. Okay, now except Li2CO3. Li2CO3 is exception in this group. It will give you upon heating Li2O and CO2. Now, heating of alkaline earth metal. Alkaline earth metal carbonate. Alkaline earth metal means like MgCa, although strontium and barium are also there, but those carbonate I am not talking about them. Those are stable to heat. Means if you heat carbonate of strontium and barium, so it's very difficult to obtain any product. Now let's see. If you heat MgCO3, it will give MgO plus CO2. Just like this, Li2CO3. Here what is Li2O? Lithium oxide. What is MgO? Magnesium oxide. CaCO3 upon heating, it will give you CaO plus CO2. What is CaO? Calcium oxide. MgO, magnesium oxide. Li2O, lithium oxide. Like that. Okay, moving to the next. Now, heating of first A nitrate. First A means alkali metal nitrate. Nitrate formula is NO3 minus. So if you heat NaNO3 means alkali metal nitrate, or KNO3 or RbNO3 or CsNO3, so you get NaNO2. What is NO2? NO2 we call it nitrite. Nitrite. Formula for nitrite ion is NO2 minus. So you get sodium nitrite and plus oxygen. For balancing purpose, let's see, here we have 3 oxygen. Here we are having 4 oxygen. So for balancing purpose, by heat and trial method, I multiplied here with half. So by half multiplying, here how many total oxygen atom I can see? Can you tell me? Total oxygen atom here. See, each O2 contains 2 oxygen atom. Each O2 contains 2 oxygen atom. How many O2 you can see here? Half O2. So one O2 contains 2 oxygen atoms. So half O2 will contain 1 oxygen atom. So it is nothing but here I have total 1 oxygen atom. Remember, sometimes you make mistake in such silly things. Okay. Now, but lithium, as I said, it is black sheep. Okay, it goes always opposite to its own group. So LiNO3, when you heat it, it will give you Li2O plus 2NO2 and plus half O2. Means it gives you Li2O oxide, NO2 nitrogen dioxide and O2. Okay. Now although these two reactions are not that important, previous reactions were important. Okay, now this is also important. Heating of carbonate or oxide of heavy metal. Heavy metal means like silver, mercury, gold, lead, etc., etc. Okay. So if you heat silver oxide, so these metals, see, these heavy metal, are they reactive or they are less reactive? They are less reactive. So they don't want to form many compounds. So whenever you heat their compound, they have tendency to give pure metal back. Okay. So if you heat Ag2O, so what you will get? Silver will be deposited separately and O2 will be released. So how many oxygen you can see here? 1. For balancing purpose, I will write here how many O2? Half O2. You're getting this thing. Okay. So if you wish to, you should know how to balance the reaction by heat and trial method. Now, if you heat the carbonate of silver, so what you will get at first? You will get at first Ag2O and CO2. But what if I heat Ag2O also? Or strong heating, upon strong heating, so Ag2O will further give you 2Ag plus half O2. Are you getting this thing? But don't think like if I will heat MgO, I will get Mg plus O2. No. Magnesium, sodium, they will not give you metal. This will be valid for heavy metal only. Don't make such stupidity. Na2O, let's heat and we'll get Na plus half O2. How? Sir told us about Ag2O. No. Don't do like that. This will not be formed. Got it? Good. Now, similarly, suppose you have HgO. So if you heat HgO, what you will get? Hg separate and O2 separate. For balancing purpose, multiply it here by half. Okay, let's move to the next reaction. Now, next reaction is combustion. Combustion, it is most important. So you just remember, if we perform combustion for any compound, so whatever carbon is present over there, that carbon will be converted to CO2. Whatever hydrogen is present over there, that hydrogen will be converted into H2O. Whatever sulfur you have over there, it will convert into SO2. Although sulfur you will not find so much, but still you should know. Whatever nitrogen you will find, that will mostly convert into N2. This much you should know. Okay. Now let's take an example. Suppose you have CH4. Combustion means you will perform its reaction with O2. So CH4 plus O2, what you will get? Let's see. Entire carbon will convert into CO2. So how many carbon you can see here? 1. So you will get how many CO2? 1 CO2. Okay. How many hydrogen you can see here? 4. Now entire hydrogen will be converted into what? H2O. So you will find H2O. Now how many H2O you will get? See, each H2O contains how many hydrogen? Each H2O contains 2 hydrogen. How many hydrogen you can see here? 4. So 2H form 1 H2O. So 4H will form how many H2O? 2 H2O. So for balancing purpose, I will write here 2 H2O. Okay. Now carbon and hydrogen both are balanced in this reaction. Now our task is to balance now oxygen atom. So see how many oxygen atom you can see here. How many oxygen you can see here? Here we have 2 oxygen atoms. How many oxygen you can see here? I can see here each H2O contains 1 oxygen. So 2 H2O will contain 2 oxygen. So total oxygen how many? 2 and 2, 4 oxygen. So here also how many oxygen you should have? 2. So let's multiply by 2. Regarding this thing. Good. Now let's see. Suppose we have C2H5OH. Let's perform the combustion of this reaction. C2H5OH is undergoing combustion. Now what we will get? Let's see. How many carbon you can see here? 2. So entire carbon will convert into what? CO2. Try to pause the screen and try to solve it on your own. Let's see whether our answer matches or not. So here we have 2 carbon. So 2 carbon will give me CO2, but not 1. 2 CO2 plus. How many hydrogen you can see here? See 5 here and 1 here. Total hydrogen 6. Entire hydrogen will convert into water. So how many water molecule I will get here? How many water molecule I will get here? 3. Because 6 hydrogen are there now. So I will get 3 water molecule. Good. Now how many oxygen you can see here? See 2 and 2, 4 oxygen. Each CO2 contains 2 oxygen. So 2 CO2 will contain 4 oxygen. Can you see this? Each CO2, 1 CO2 contains 2 oxygen. So 2 CO2 will contain 4 oxygen. So here we have 4 oxygen. Can you count oxygen here? Here how many oxygen we have? 7. Here we have 7 oxygen. Oh sorry, what I wrote. Sorry, I forgot. Here we have 3 oxygen. Total oxygen are 7. Actually, I was thinking 7 in my mind total. So I wrote 7 here. Pardon me. Now, how many oxygen I can see here? 3. So total oxygen on right side, 7. So left side also how many oxygen should be present? 7. Let's try to balance. Now, how many oxygen you can see here? 1 oxygen. 7 here, 1 here. Here we have 1 now. How many left? 6. This side 7 now. So here we need 6 more. Now, how many O2 will I be required? I will be required 3 O2. I will be required 3 O2. So that how many oxygen you can see here? Each O2 contains 2 oxygen. So 3 O2 will contain 6 oxygen. Now this reaction is completely balanced. Okay. Now let's take a general reaction for any hydrocarbon. So let's say we have hydrocarbon CXHY. If we perform hydrocarbon, do you know carbon and hydrogen form? Very good. So if we perform combustion here, so what we will get? Let's see. We have how many carbon here? X carbon. So we will get X CO2. We will get X CO2 plus how many hydrogen you can see here? Y. You can see here Y hydrogen. So when we have 4 hydrogen, we got just 2 water in just half. When we have 6 hydrogen, we got 3 H2O, just half. So when we have Y hydrogen, we will get Y by 2 H2O, just half. Are you getting this thing? Good. Now let's balance oxygen. Now how many oxygen you can see here? 2x. Each CO2 contains 2, so X CO2 will contain 2x. Now how many oxygen you can see here? Each H2O contains 1, so Y by 2 will contain Y by 2. So right hand side, how many oxygen you can see? 2x plus Y by 2. These many oxygen you can see on the right side. Good. Now, so we need same amount of oxygen here also. Same number of oxygen here also for balancing the reaction. So I hope you understand if whatever number I will write here, let's say I wrote here ZO2. So how many oxygen atom I will have here? Each O2 contains 2 oxygen. So ZO2 will contain 2Z oxygen. भाई एक O2 में आपके 2 ऑक्सीजन है, तो ZO2 में कितने ऑक्सीजन होंगे? 2Z. Now this 2Z must be equals to 2x plus y by 2. ना right side हमारे 2x plus y by 2 है ना. So what will be the Z? Z will be x plus y by 4. For balancing purpose, what will I write instead of Z? I will write x plus y by 4. This is the balanced combustion reaction for any hydrocarbon. Okay, and this reaction is very important to us. That's why I gave so much time on this. Is this thing clear? Good. Let's move forward. Now, as we have seen some basic reactions, let's start with an easy problem. Okay. So here, question is saying, you find the moles of HNO3 required to react with 2 moles of CaOH whole twice. And they have given you the reaction as well. CaOH whole twice plus HNO3 gives us CaNO3 whole twice plus water. Question is clear? Good. Now, first step, what will be the first step for this reaction? First step will be, we should form a balanced reaction. Okay, they have given us a reaction. If they haven't given, we will try to form reaction on our own. But for that purpose, you will require some practice. Once you will be solving some questions, you will see कि I have started making the reaction, and then questions will be very easy for you. Now, what they are saying? They are saying CaOH whole twice plus HNO3 gives us this and this. First step, let's make a balanced reaction. So can you see this reaction is balanced? Can you see? No, this reaction is imbalanced. It is not balanced. So let's balance it. So how many nitrogen you can see here? 2. How many nitrogen you can see here? 1. So just multiply it with 2. Okay, it is hit and trial method purely. Okay, and there is no other method for balancing. We just have to go for hit and trial method. Means try करो, देखो सही हो रहा है, good. Otherwise, I'll try one more time. Okay. Now, how many calcium I can see here? I can see here 1 calcium. Here also 1 calcium. Now, how many hydrogen here? 2 here and 2 here. 4 hydrogen on left side. How many hydrogen here? 2 here. So let's multiply it with 2, so that I can have 4 hydrogen. Now, is this balanced reaction? Let's see. 2 oxygen, 3. Yes, everything is balanced here. So this is our balanced reaction. Now, what does balanced reaction say to us? It says, see here, what is written? 1. Here it is written 1. So 1 mole of HNO3 reacts with how many mole of HNO3? Oh, sorry, 1 moles of COH whole twice reacts with how many moles of HNO3? 2. This is the relation I am talking about. And when they both react, how many CaNO3 whole twice they give us? They give us 1 CaNO3 whole twice. And how many water molecule they give us? They give us 2 water molecule. So I will write here कि 1 CaNO3 whole twice reacts with how many HNO3? 2 HNO3. Can you say this thing? 1 reacts with 2. But how many COH whole twice you have? You have 2 moles of COH whole twice. You don't have 1, you have 2. Means you are rich. So, tell me, 2 moles of CNO3 whole twice will react with 1 reacts with 2. So, 2 moles will react with 2 into 2, that is 4 mole of HNO3. Are you getting this thing? Good. Clear? 1 reacts with 2, so 2 moles will react with 4 mole of HNO3. I think this thing is clear to us? Good. Move forward. Next problem is, find the weight of N2 required to form 51 gram of ammonia. Reaction is given, N2 plus 3H2 gives us 2NH3. Now this is my second favorite reaction. My first favorite is A plus 2B gives us 3C plus 4D. And this is my second favorite reaction. Why? Because I hope you can see what is the stoichiometric coefficient of N2? 1. What is the stoichiometric coefficient of H2? 3. What is stoichiometric coefficient of NH3? 2. So all these 3 stoichiometric coefficients are different. So it allows me to generate different data. That's why this is my second favorite. But remember, my first favorite is A plus 2B plus gives us 3C plus 4D. So whenever I say, if my favorite reaction write do, so don't forget to write A plus 2B gives 3C plus 4D. Okay, now let's see. I hope you can see here what is the relation. Relation is 1 mole of N2 reacts with, tell me, how many moles of H2? It reacts with 3 moles of H2 and form how many moles of ammonia? 2 moles of ammonia. Are you getting this thing? Means whenever 1 N2 and 3H2 will react, they will form 2NH3. This is a relation. Where it is written? Here. Okay. Now, we have to relate what? N2 with NH3. We don't have to relate H2 here. So let's remove H2. Okay. We don't need H2 here. So tell me one thing. If I want to form 2NH3, so tell me, it requires how many moles of N2? So 2NH3 requires 1 mole of N2. Are you getting this thing? Means again I am writing 2 moles of NH3 requires 1 mole of N2. I hope you can see here. If you want to form 2 mole of ammonia, so you will require 1 N2. Good. Now, let's find out how many NH3 we have. So, moles of NH3. How many moles of NH3 we actually have? This is actual. This is relation. This is relation. Where it is written here. But how many gram of NH3 I want to form? I want to form 51 gram of ammonia. So let's see how many moles of ammonia I have. Okay. भाई मुझे 51 ग्राम अमोनिया फॉर्म करनी है तो देखना पड़ेगा ना कि मेरे पास कितने मोल्स हैं. लेट्स सी. सो मोल्स ऑफ ammonia will be weight in gram divided by molar mass. What is molar mass of ammonia? Nitrogen 14, hydrogen 1. So 3 hydrogen 3. So divided by 17. How many it is coming? 3 moles. Oh my god. 2 moles of ammonia require 1 mole of N2. But I don't have 2 moles. I am rich again. How many moles of ammonia I have? 3 moles. So tell me, 2 moles of ammonia requires 1 mole of N2. So 1 mole of ammonia will require how many moles of N2? 1 upon 2 mole of N2. Can you see? 2 rupee, 2 toffees cost 1 rupee. So 1 toffee will cost half rupees. So 1 mole of ammonia will require half mole of N2. But I don't have 1 mole. I have 3 moles. So 3 moles of ammonia will require how many moles of N2? Half into 3, that is 3 by 2 moles of N2. 3 by 2 moles of N2. So did they ask us moles of N2? No, they asked us weight of N2 required. They asked us weight of N2 required. So now tell me, weight of 1 mole of N2. What is the weight of 1 mole of N2? 1 mole of N2 has weight 28 gram. Why? Because 28 is the molecular mass of N2. Okay. So what is the weight of 3 by 2 moles of N2? 3 by 2 moles of N2 will have weight 28 multiplied by 3 by 2. 2 cancel out 14. 14 3s are 42 gram. Is this clear to us? How I did it? By unitary method. 1 mole has weight 28. So 3 by 2 will have this. I hope question is clear to us. Now, I am writing so much here. I am not habitual to it. Let me tell you honestly. I am not habitual of writing this much. I say that 1 mole of NH3 will require this. So I will not be writing this everything in detail, because it requires so much handwork. It requires so much board work. Since I know that 1 rupee give me 2 toffees, so 2 rupees will give me 4 toffees, I can do it on my fingertips, I can do it verbally. So I will, after some time, I will not be writing this much. I will reduce my writing, and you will not get the idea when I did this. You will see it is being done automatically. Okay, so stay tuned. Now let's move to a very important concept of this topic called limiting reagent. Now what is limiting reagent? Although I have already made a video on limiting reagent, link to that video you can find right up here. But let's quickly revise it. What is the meaning of limiting reagent? Limiting reagent is the reactant which gets fully consumed, but what happens, it leaves behind other reactants. Okay, means if you have more than one reactant, if during the reaction one of those get fully consumed, we call that reagent as limiting reagent, and the other reactant will be called excess reagent. Okay, limiting reagent which gets fully consumed, excess reagent which gets remaining. So for us, limiting reagent is important. For us, limiting reagent is important. Why? Because limiting reagent decides what amount of other reactant will be consumed. What amount of other reactant will be consumed and what amount of product will be formed. Means it is the limiting reagent which will decide what will be the amount of other reactant that will be used or what amount of product will be formed. So it is very important to us. Okay, let's take a very quick small example, home used example. Let's say I give you a recipe to form 1 bowl cooked dish, and the recipe is if you have 1 bowl of mixed veg and if you have 1 spoon salt, so you will get 1 bowl cooked dish. So for making 1 bowl cooked dish, that is our product, you need 1 bowl of mixed veg and 1 spoon of salt. If you have these two 1 you'll get 1 bowl of very good cooked dish. Okay, now let's see, take a scenario when we have 2 bowl of veg and 7 spoon of salt. 2 bowl of veg and 7 spoon of salt. So see, if you have 1 spoon of salt, so it will give you 1 bowl cooked dish. Now you have 7 spoon salt. So how many cooked dish you can form? How many bowl? You can form 7 bowl cooked dish. But for 7 bowl cooked dish, you need how many bowl of vegetable? You need 7 bowl of vegetable. But how many bowl of vegetable you have? Just 2. So can you cook 7 bowl of vegetable here? No, you have just 2 bowl veg. So since I have just 2 bowl veg, so I will not use all 7 spoon over here. I will use how many spoon salt? I will use just 2 spoons salt. These will be used. So how many bowl of cooked dish I will form? Just 2. Just 2. Why? Because I don't have raw veg in excess amount. I have very limited amount of this raw veg. So due to which this will be called our limiting reagent. Are you getting this thing? Okay. Now fine. See, if I take a case where I have 7 bowl of raw veg and I have 3 spoons salt. So can you guess how many good quality dish will be found? How many bowl of good quality dish will be found? Can you answer this? Yes. See, if I have 1 of both, so I get 1 bowl of dish. Now I have 7 bowl veg. So I will require how many spoon of salt? I will require 7 spoon of salt, but how many spoon of salt you have? Just 3. So since you are lacking at salt, so you cannot make 7 bowl of very good dish. But you can make, suppose if you remove out of this 7, you remove 3 bowl veg separate. Now if you mix this with 3 spoons salt, how many bowls of cooked dish you will get? 3 bowls. We're getting the same. So we are preparing dish on the basis of what? Salt or veg? We are preparing dish on the basis of salt. So that is why this will become our what? Limiting reagent. Because it is getting over during the reaction. And who is limiting agent here? Okay, I hope this scenario is clear. Now let's take the let's see the step to find limiting reagent. How do we find limiting reagent? We find limiting reagent for first step is find moles of each reactant. You will have to find moles of each reactant. First step is. Second is divided by stoichiometric coefficient. So whatever the stoichiometric coefficient of that reactant is, you will have to divide it by that. Okay. Third step is compare the values obtained in step 2. Means you have to compare these values. Whatever you will get in this step. Compare the values obtained in step 2. Now fourth, smallest of 2 will be limiting reagent. Whatever the smallest will be there, it will be limiting reagent. And limiting reagent is very important to us. You just remember this. Okay, now let's see. Let's take a very easy example. Say, suppose I have this 2A reacts with 3B, which further reacts with 5C, and they give us product. Means how many reactant I have? 3. When 2 moles of A react with 3 moles of B and 5 moles of C, we get product. Okay. Now let's see. How many moles of A I have taken? I have taken 7 moles of A. How many moles of B I have taken? 9 moles of B. How many moles of C I have taken? 13 moles of C. Okay. Now they are asking how many moles of product will be formed? How many moles of product will be formed? Or leave how many moles of product will be formed. Let's find a limiting reagent. This is our aim. So what is our first step? First step is find mole of each reactant. So see, we already know the moles of each reactant. So first step is over. Now second step is divided by mole stoichiometric coefficient. Now I will divide 7. I will divide 7 by whom? By 2. 7 by 2. Okay. Now 9. 9 I will divide by what? Sorry, 9 I will divide by stoichiometric coefficient of B, that is 3. Again, this is 13. Now this 13 mole I will divide it by what? 5. So here I am getting 3.5. Here I am getting 3. And here I am getting 2.8. Sorry, 2.6. Are you getting this thing? 3.5, 3, 2.6. Now third step is compare the values obtained in step 2. So these are the values I am getting, 3.5, 3 or 2.6. Which one is the smallest? Smallest is 2.6. So this is your smallest. So now since this is the smallest, so what will be your limiting reagent? C. C will be limiting reagent. Okay, this is how we find limiting reagent. Now if in any question you are given about amount of all reactant present, first of all, in order to form product, you will find moles of each reactant first and limiting reagent simultaneously. You have to find limiting reagent at any cost, because without knowing the limiting reagent, you cannot decide the amount of product. Because who decides the product? It is the limiting reagent which decides the amount of product formed or reactant reacted. Is this thing clear to us? So our first aim will be to find limiting reagent in all such questions. Okay, let's move forward. So let's see a similar problem. What it is saying we have 32 gram of O2 and 16 gram of CH4 in a vessel. Find the amount of CO2 formed after the combustion. Means whenever combustion will happen, see, we have taken CH4 and O2. So the only reaction possible is combustion. So they are saying what amount of CO2 will be formed. Now let's try. So first of all, we will have to make the combustion equation. So CH4 plus O2 will give us CO2 plus H2O. Entire carbon converting into CO2, entire hydrogen converting into H2O. For balancing, 2H2O, 2O2. We have already done this. Okay. Now, I have taken here 16 gram. I have taken here 32 gram. This is the weight that I have actually taken. Let's find the moles of these. Now, moles. Here, moles will be 16 upon 16. What is molecular mass of CH4? 16. So it will be 1. What will be the moles of O2? O2. O2 moles will be 32 divided by 32. Oh my god, that is also 1. You're getting this thing. This 16 is what? This 16 is amount given. See, 16 amount given. And what is this 32? 32 is amount given here as well. I hope this thing is clear to us. Now, I have taken both 1 moles. I have taken both 1 mole. Now let's see. Can you feel this thing? What will be our next step? As I said, I will have to divide this number of moles. I will have to divide this number of moles by stoichiometric coefficient. What is the stoichiometric coefficient of CH4? 1. So I will divide 1 by 1. What I am trying to do here? I am trying to find limiting reagent. This limiting reagent work you can do in the rough as well. So if you don't want to do in fair, you can perform this calculation in rough. Because finding limiting reagent is rough work, we actually have to find the moles or weight of CO2. So let's do it in rough. So how many moles of CH4 I got? 1. How many moles of O2 I got? 1. 1. What is the stoichiometric coefficient of CH4? 1. What is the stoichiometric coefficient of O2? 2. So now I will divide 1 by 1. 1 divided by stoichiometric coefficient. Now I will divide this 1 by whom? 2. Stoichiometric coefficient. Here I am getting 1, here I am getting half. Which one is the smaller? 1 or half? I hope you can understand that this one is smaller. So whatever the smaller, whichever will give us this a small number, that will become our limiting reagent. So who is limiting reagent? O2. Now that's what I am mentioning here. The O2 is limiting reagent. Is this thing clear to us? Limiting reagent finding clear? Good. Now let's see one more thing. Once I have found limiting reagent, but our task was not to find limiting reagent. Our task was to find amount of CO2 formed. Now, who is going to decide what amount of CO2 will be formed? Will it be CH4? No, it will be O2. Always limiting reagent decides what amount of product will be formed. Now let's see. I am writing one thing. Now I am writing 2 moles of O2 forms 1 mole of CO2. How did I write this? I wrote this because of this relation. See, in this relation, what is written? If 1 CH4 reacts with 2 O2 to give us 1 CO2 and 2 H2O. Means whenever 2 O2 will react, so I will get 1 CO2. Clear? But do I have 2 moles of O2? No. I have how many moles of O2? Just 1. I have just 1 mole of O2. I am poor this time. So 2 moles of O2 forms 1 mole of CO2. So 1 mole of O2 will form. Tell me how many moles of CO2? 1 upon 2 moles of CO2. Can you see this thing? Good. Now, but they did not ask us the moles of CO2. They asked us about amount of CO2. So let's tell them amount in gram. So do you know what is the weight of 1 mole of CO2? So 1 mole of CO2 has weight equals to 44 gram. 1 mole of CO2 has weight how much? 44 gram. So half mole of CO2 will have weight how much? 1 mole has weight 44 gram. So 44 is molecular mass of CO2. So half mole will have weight how much? Half into 44, that is 22 gram. Clear? Very good. Although they did not ask us about the amount of other reactant left. What will be the other reactant left? If O2 is our limiting reagent, so who will be excess reagent? CH4. CH4 will be excess reagent. So let's see how much amount of CH4 has reacted. Let's see. Who will decide what amount of CH4 will react? Will CH4 decide? No. Always limiting this reagent decides everything. So who will decide what amount of CH4 will be, who will decide what amount of CH4 will be reacting? It will be decided by limiting reagent. Let's see. Now, can you see? I am writing one thing. If you don't understand, let me know. 2 moles of O2 react with, let me write it again. 2 moles of O2 reacts with 1 mole of CH4. Where it is written? It is written in the relation. But do I have 2 moles of CO2? No. 2 moles of O2? No, I have just 1 mole of O2 as I am very poor. So 1 mole of O2 will react with 1 upon 2 moles of CH4. Are you getting this? So from here I am writing moles of CH4 left. Moles of CH4 left. How many? Initial minus reacted. How many initial moles of CH4 I had? 1. How many moles reacted? Half. So these are the half reacted moles. So I will get half moles left. Are you getting this thing? Although they did not ask about the moles of CH4 left, but still by this you can easily find it. Okay, good. Moving forward. Next question is, find the moles of BaSO4 formed when 1 molar 2 liter H2SO4 is mixed with 0.5 molar 3 liter BaCl2. Okay, question is clear to us? Means 1 molar 2 liter H2SO4 and 0.5 molar 3 liter BaCl2 are mixed. They are asking what will be the moles of BaSO4 formed. Okay, let's try to make the reaction about this. What is happening here? It is happening that we have BaCl2, we are mixing it with H2SO4, and they are saying what is being formed? BaSO4. They are saying this. So can you guess another byproduct? Cl is left, H is left. So what will be the byproduct? HCl. Now balance this reaction. How will we balance this? Ba1, 1 Ba, Cl2, here 1 Cl, no, let's make it 2. So 2 H2SO4, 2 BaSO4. Okay, fine. Now, let's find here. We have found the correct balanced reaction. Now let's find how many moles of each reactant I have. Now, can you tell me? Moles of BaCl2. How many moles of BaCl2 you have? How many moles of BaCl2 you have? Say you have 0.5 molar 3 liter. So how do we find moles? Molarity multiplied by volume in liter. So how many moles we have? 0.5 into 3, which is coming as 1.5 moles. Okay. Similarly, moles of H2SO4, it will be how much? It will be 1 into 2 equals to 2 moles. So here I have 1.5 moles and here I have 2 moles. Clear? Good. Now tell me one thing very honestly. Will I solve the question directly? No. I will find first of all limiting reagent. For limiting reagent finding purpose, what will I do? I will divide these moles by stoichiometric coefficient, but in the rough. So first let me write here BaCl2 and here I will write H2SO4. Here is stoichiometric coefficient 1, here is stoichiometric coefficient 1. Now here how many moles I have? 1.5. Here how many moles I have? 1.5. So let's divide this 1.5 by 1. And oh sorry, here H2SO4 moles I have 2. So let's divide this 2 by 1 also. So I'll get what? I'm getting here 1.5, here I'm getting 2. Which one is smaller? This. This one is smaller. Since this is smaller, so who will become limiting reagent? BaCl2. This will become limiting reagent. Now who will decide what amount of product will be formed? It will be BaCl2 or H2SO4. Always limiting reagent means it will be the BaCl2 who will decide what amount of product will be formed. Now I hope you can see if 1 mole of BaCl2 forms 1 mole of BaCl2 forms how many moles of BaSO4? 1 mole of BaSO4. This thing is clear to us? Written in the relation only. 1 BaCl2 react with 1 H2SO4 to give us 1 PSO4 and 2 HCl. But do I have just 1 mole of BaCl2? No, I have 1.5 moles of BaCl2. This time I am rich. So 1.5 moles of BaCl2 will form 1.5 moles of BaSO4. Are you getting this thing? Okay, please pardon the background noise. I hope it is clear to us. Now, I will stop writing this language all the time. I will simply draw this. See, 1 mole forms how many moles of BaSO4? 1. So 1.5 will form how many moles of BaSO4? 1.5 direct. In this arrow is originated from this and it is going towards this. Here in this arrow it is written automatically, which is invisible. It is written here, he forms. It is directly written here. The 1.5 mole forms 1.5 moles of what? BaSO4. I hope this thing is clear to us. Okay. Now I have attached a DPP based upon the very simple problem on this topic only. Tomorrow in the next turn we will be discussing some more problems, some more concept about stoichiometry only, and try to solve the question which is attached with DPP in the comment section, and go through the video of limiting reagent. As I told you, I have already taught this limiting reagent one more time. Rest we will discuss in the next video. Okay, till then, take care. Bye bye.